Alright guys, so we are in section 8.1 and we are going to correct the first example. So in this section 8.1 we are just talking about sign of trigonometric function. And remember that basically what we have is we have quadrant, and the quadrant are rotating in the counterclockwise. So we have quadrant 1 right here, quadrant 2 right here, quadrant 3 right there, and quadrant 4 right here. Remember that when we are reading the angle, we are reading the sinus on the vertical axis and the cosinus of my angle on the right axis. So when I calculate, let's call this the terminal side, and this terminal side is defined with a value of y right here and a value of x right here. When I am in quadrant 2, like in this example, I can see clearly that y is positive and x is negative. You will always have r positive because r is the square root of x squared plus y squared, and r will be always positive. So when you are looking at the cosinus of your angle, in that case, you got x over r, and it's going to be negative because x is negative and r is positive. Now, if you look at the sinus of your angle, it's y over r, and both are positive, so you will end up to have something positive. On the other hand, the sign of tangent is going to be y divided by x. Y is positive, but x is negative, so your tangent will be negative. What are all the others that I can work with? I could work with the cosec of the angle, which is one of the sinus of the angle. Because sinus is positive, one of the sinus will be positive, so my cosec will be positive. On the other hand, sec of the angle theta, which is 1 over cosinus of the angle theta, and it's not x because sometimes we can call the angle theta x. Cosinus theta is negative, so the sec of theta will be negative. Finally, the tangent, the cotangent of the angle, which is 1 over tangent of the angle, will be negative because tangent is negative. All right, problem number 5. All right, let's jump on to problem number 5. On this problem number 5, determine the sign of the given function. So we have sinus 290 degree and cosinus 200. So we need to find the sign, the sign of sinus 290 degree and cosinus of 200 degree. So when I look at this is 90 degree, this is 180 degree, and this is 270 degree. So basically, theta equal 290 degree. That means that I will be in quadrant 4. Okay, this is my quadrant 4. Quadrant 1, 2, and 3. On the other hand, for theta equal 200 degree, I will be, so this is the angle theta right here, 290 degree, but 200 degree will be somehow, let's say around right here, with an angle of 200 degree. When I look at, and so that means I will be in quadrant 3. So when I am in quadrant 4, what do I have? When I am in quadrant 4, I have x positive, x is positive, and I have y negative. The sign, I always remember that r is positive, and so the sinus of the angle, which is y divided by r, will be negative because y is negative. Now, on the other hand, for theta equal 200 degree, I can see clearly that x is negative, but y is negative as well. And so I'm getting a x negative and y negative. No matter what, I will deal with r always positive, and the cosinus of 200 degrees, so the cosinus of my angle theta, which is x divided by r, is negative, because x is negative and r is positive, so it will be negative. All right, problem number 17. On this problem number 17, find the trigonometric functions of theta if the terminal side passes through the given point. So we have x equal 2 and y equal 1. So first of all, what I want to calculate using the Pythagorean Theorem is calculate r. And r equals the square root of x squared plus y squared. So that implies that r will be equal to the square root of 2 squared plus 1 squared, which is the square root of 5. So now, if I want to calculate the trigonometric function, I'm going to say the cosinus of my angle is going to be 2 divided by square root of 5. And obviously, I want to get rid of the square root of 5, so I'm going to multiply top and bottom by my denominator, which what we call rationalizing the denominator, which is getting rid of the square root on my denominator, and the answer is going to be 2 square root of 5 divided by 5, because square root of 5 multiplied by square root of 5 equal 5. I can do exactly the same work with sinus of my angle, which is now 1 over square root of 5. I will multiply by the square root of 5 top and bottom, and so I end up to have square root of 5 divided by 5. Tangent of my angle, I could easily remember it's y divided by x, so it's going to be 1 divided by 2. The sec of my angle, which is 1 over cosinus theta, it is going to be it is going to be square root of 5 divided by 2. Why is it going to be square root of 5 divided by 2? Because I'd like to remind you that cosinus of my angle is 2 over square root of 5. So no need for me to work with the expression that I found right here, because it will force me to multiply again one more time to get rid of the square root of 5 on the bottom. I know right away right here that there is no need. The cosec of my angle, which is 1 over sinus of my angle theta, which is going to be finally square root of 5 divided by 1, which is square root of 5. And the cotangent of my angle, which is the 1 over tangent, and in that case 2 divided by 1, which is going to be equal to 2. Alright, so in this problem number 21, I tried to do the problem a little bit before to be able to be in the timeline of this video. We have a point and find the trigonometric functions of an angle theta if the terminal side of theta pass through the given point. So x equal negative 0.5 and y equal 1.2. I calculate r. When you deal with a negative number, don't forget to use your parentheses, even though in that case it should be okay. If you're not putting a parenthesis, just to remind you that when you have negative 0.5 and if you put the square without using the parentheses, this is going to be negative 0.25. But if you put negative 0.5 and you are using the parentheses, then you're going to have plus 0.25. I hope you can see the differences. So then when I have r, I can calculate the value of cosinus, which is x over r, which is sinus theta, which is y over r, and tangent theta, which is y divided by x. For the sec, it is going to be the inverse of cosinus. For the sinus, is going to be for the cosec is going to be the inverse of sinus, and for the cotangent is going to be the inverse of tangent. On the problem number 5, it's all about finding the angle theta to finally be able to define in which quadrant you are. When you are calculating theta, you find that the angle is 30 degrees, and 30 degrees is corresponding to the quadrant number 1. I'd like to remind you on the problem number 31 right here below that the quadrant number 1 is right here, quadrant number 2, quadrant number 3, and quadrant number 4. On the number 31, you have sinus positive and cosinus positive. In which quadrant are you? Well, all the value of where sinus will be positive are underlined in blue, and where it's green, it's where cosinus of my angle is negative. And so the only place that can satisfy both is in quadrant number 2. Finally, for the problem number 43, when you are on quadrant 4, what is the sign of y over x? Y being negative when you are in quadrant 4. Actually, I'm going to use another color. So y being in quadrant 4, y is negative right here. And if I look at x positive is right there. And so obviously this only the quadrant 4 will satisfy that we're having y negative and x positive. Alright guys, this section 8.1 is done. It's all about basically understanding that we have a 4 quadrant where x, y can be positive and negative, and that is going to have some influence on the sign of your cosinus. So depending in which quadrant you are, the cosinus, the sinus, the tangent, the secant, the cosecant, and the cotangent will have different signs.